email this real quick to you guys. So I have, well, I might be able to just add it into the little thingy revolver. Maybe not. It's fine. All right, I'll figure it out later. It's fine.
All right.
Okay, let's do this. The symbol for true population proportion is which of the following? True population is, I had it in my book, hold on. Okay, true population is just P.
Right, yes.
Let me leave this out, actually. Okay. Information for the next two questions. Suppose N, P, and P hat. The requirements for construction or for constructing a confidence interval are satisfied.
Let me look at the book on that one. I want to say true, but I'm not 100% sure on that.
Let's see. So the requirement, like other procedures, there are requirements that must be checked in order for this confidence interval to be valid.
Where are you reading that at?
2.2.1.
Okay, on chapter 17. So
Yeah.
I went back to chapter 16, because I wasn't quite sure. 2.2.1.
The confidence intervals are valid when NP. Oh, okay, so we just have to check that and make sure that's valid, basically. We all remember those equations?
It's right there in there. It's N P hat is equal to 10, and then the N then 1 minus P hat is not equal to 10.
Okay.
That was from the last chapter? Is that from the last chapter?
No, it's actually in this chapter, 2.2.1.
Okay. So if, let's see. Let me pull out my calc key. So if N equals 100 and P hat equals 0.10, 100 times 0.10, that's 10. So it satisfies the first one. Let's see about the second one. So 100 times 0.90 equals 90. So yeah, it satisfies both.
Yeah.
Okay.
That's true. The requirements for conducting a hypothesis test are satisfied.
Yes, because there's a large sample.
Okay. Find P hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state. Okay. So we have to find P hat. P hat is X over N.
So it's 45 over 60.
And that is?
That is 0.75.
Yeah, 0.75. And we need to use the formula of confidence interval.
Okay. Okay, margin of error. Margin of error, let's see where.
It's on 2.2, I think.
Is it 2.2?
Yeah.
No, it's not. It's down lower. It's
See?
under 2.4. If you scroll down below the blue box, the margin of error.
Okay. All right.
So we need the z-score. So let me pull up the probability applet. Why are you doing that?
What was P?
Hello, P.
Hi.
Peace?
Yeah, hello.
Hi, how are you?
I'm okay.
Good. Just tired.
Sorry.
Okay.
Do we need to use the applet?
Yeah, mine's not working for some reason. There, now it's working. Okay. So it's going to be, according to that, do we need to catch Peace up to where we're at?
Mm-hmm.
Okay.
Okay, Peace, so we are doing the homework quiz.
Okay.
If you want, or sorry, the group meeting quiz. If you want to go ahead and open that up, we'll tell you the answers we have so far.
Okay.
Guys, my hair's so greasy. Look at that. Nasty.
Well, if you weren't afraid of water,
I
maybe
know.
you'd wash your hair.
I know. I just gotta spray my dry shampoo in. Because, you know, girl things. Okay. Peace, do you have that group meeting quiz open?
Yes.
Okay. So question 1 and 2 obviously are true. Question 3 is just the regular P. So C. Question 4 is true. And question 5 is true as well. Question 6 is 0.75.
Okay.
And then we're on question 7 right now.
Thank you.
Okay, guys, I'm done. I'm sorry. All right. So, number 7, what did you say the z-score was?
Z-score is 1.645.
1.645.
So the way that I'm writing the formula is that it's 1.645 times, and that putting everything into the square root, is 45 times 44 divided by 60. Because P is 45, right?
Yes.
Okay.
Yeah. Over what? I'm sorry. Over 60.
Over
right?
60.
Yeah. Okay. So what was the answer that you were able to get?
It didn't get it, so I need to put it on a spreadsheet to do it.
Okay. Happy International Women's Day, guys.
I like National Pizza Day personally,
Yeah.
and National Ice Cream Day.
That one too. My hair is finally starting to fade, in case anyone cared.
One
Did you
point six four five.
Yeah.
Okay.
I dyed it about, I want to say about 3 to 4 weeks ago.
Wow.
It's just now starting to fade. I love it. It's a lot of fun. It's just a little bit crazy. Okay.
All right, so I'm working on it here.
You're good.
Equals 1.645 times this. Oops, I'm going to put that in parentheses. This times parentheses again 1 minus 1 is that.
Okay. I think I got the answer.
All right. Well, let's see if we match here. It didn't give me an answer. Why isn't that? I mean, oh, because it turned out to be negative. How did I get a negative number?
Oh, really?
Yeah. Because I got 1.645 times 45.
Oh, yeah, it's going to be a negative because it's 45 times negative 44.
Oh, okay.
Because 1 minus 45 is negative.
Right. Okay. But so then it doesn't give me a square root off of that.
I just did square root of 33, just like a positive 33, and then multiplied that whole thing by the 1.645.
So where'd you get the 33 from then?
It's 45 times negative 44. and that'll give you like 1900 something. And then you
So-
divide that by 60.
All right, so 45 times negative 44.
Uh-huh.
That's what I did essentially. So let me try this again. So 1.645.
Just do it all as positives instead of negative.
Okay, okay,
And then you can just add in the negative sign.
okay. So times, then that's going to be the square root of 45 minus a negative 44, right?
Where are you at?
I'm trying to figure out where you got all your information from.
Okay, here, let me just show you.
Okay, yeah. Okay.
So I
Okay.
just, even though this 44 is supposed to be negative,
Uh-huh.
I just left it as a positive for now.
Okay.
And then multiplied that,
Yeah.
divided it by the 60, it gave
Uh-huh.
me 33. So 33 would be in here. Square
Uh-huh.
root of 33 is what I figured out.
Uh-huh.
And then I multiplied that by the 1.645.
Okay. Okay.
And then that answer is where I added in the negative.
Okay. So let me try it so I understand it. So we got a 45 minus 44.
No, not minus. Times.
Oh, times. Okay. That's where I'm messing up. Times 44. And then we're going to divide that by 60. And that's 33. And then we square root the 33. Is that right?
Square root the 33.
Okay. Square root. Oops. Okay. Square root 33.
It ends up being
Equals-
5.7445.
Yes, and then we multiply that by the 1.645.
Yes.
So then I get a 9.45. Is that
Yes.
right?
That's
Okay.
what I got. So you just add the negative to that. So it'd be
Okay.
negative 9.450.
Okay.
Okay.
Now it's asking for the lower and upper bound.
We need to use the Apple.
I think we need to use that spreadsheet because that spreadsheet is usually what tells us everything.
Yeah.
Do you remember which one I'm talking about?
No.
The spreadsheet we used a couple chapters back where we would put in the information and then it would come up with the margin of error. The mean,
Oh, I know which one you're talking about. Yeah.
that one.
Yeah, here it's the equivalence interval.
I got a fly flying around me that's starting to bug the heck out of me.
Sample, so sample.
I'm trying to get to that spreadsheet. It's not that. It's not there. It's going to be here.
So the X number would be 45. And the other would be 60?
It would be 45 and 60.
N is 60 because it's the sample, I think, but
Right.
I don't know the X. These are the values that appear. Let me show you. Oh, sorry. Continue.
Okay.
But you need to, your null hypothesis, doesn't that need to be 0?
Okay, here.
Yeah, the null hypothesis under your inputs, yeah. Doesn't that need to be a 0? Okay, so it didn't
That
change
change-
anything.
No, yeah, it does. It changed the Z-score and the standard deviation of hypothesis test. That's with 0,
Uh-huh.
and that's with 17.
Now, what about the type of test? Shouldn't it be a less than? Or is it going to be greater than?
Okay, what? Okay, let me see. No hypothesis.
So what did you get from there then?
0.640. That's the lower, and the higher 0.860. But I'm not sure if those are correct.
Yeah, I'm not. I'm reading here.
Even on a sample, the null hypothesis does not change.
Okay.
There's an example in 4.2. If you
Okay.
click on show instructions,
Uh-huh. Yeah, that's what I did.
but I think it changed.
Excuse me.
What chapter was the to get to the spreadsheets?
It might have been the second one.
Okay. You know what I'm talking about, where you click it and it takes you to that other.
Yeah.
Not the second one. Let me go to the chapter 3. Come on.
There's something similar in 2.3.
In 2.3.
Yeah, of chapter 17.
All right. I'm trying to bring up that spreadsheet so that way.
I'm trying to know what is X and N.
Yeah. Pete, are those chickens crowing out by you?
What?
Are those chickens that I'm hearing out by you?
No, I'm in the outside.
I'm so tired, guys. I can't even.
You're starting to sound tired.
Yeah, I did not think I was going to get this tired real.
Okay, let's go back to chapter 17. Oh, what? There's the on 2.2. There's the confidence intervals. So that's what we have to do right there. We're overthinking this again. Go figure.
Yeah, it's just the same numbers.
Right.
Oh,
Okay, so essentially it's
this
0.75. Here I'm trying to overthink it. So it's the confidence intervals are there on 2.2. So there's the formula that we need to use. So 45 divided by 60 is 0.75. So we got 0.75 times the square root of 0.75 times 1 minus, oops, let's start this over again here. So we got 0.75, oops, 75 minus 1, what's the z-score here? 0.645 times the square root of 0.75 times 1 minus 0.75. Oops. That's 1. Oops. Now that I've found the formula, we just plug everything in. Divide that by 60. Okay, so I have the lower limit now of 0.658.
0.658?
Uh-huh. And so then if we do 0.75, oops, not 2, 5. So let me put that down here, 0.658.
Excuse me.
And following that formula again, but plus, oh, not times, plus 1.645 times the square root 0.75 times 1 minus 0.75
Oh, where'd Peace go?
divided by 60. And the upper limit would be 0.842.
Okay.
Is Peace asleep? There she is. In and out.
So question 10 says, if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? It'll just stay the same, right?
The confidence level? No, it's going
Oh,
to,
never mind. Sorry.
the width is going to increase. No. What is that? What happens then?
I think it's going to decrease because of the P value, I think. Let me see. No, will stay the same.
I don't think it will because our number under the square root would then change.
Okay. Yeah, you're right.
So, let's see. What is 100 divided by 16? What's 100 divided by 8? Okay, it would decrease.
It would decrease? Okay.
To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals a half. What is the smallest N can be in, and both requirements been met? So let me do this real quick.
Okay. So that there's an example back there in the book again.
But that's from the last chapter.
Yeah.
Yeah, but it's also in 2.2.1.
So 10 divided by 0.5 would be 20 there.
Okay.
Where did you get the 10 from, Jocelyn?
So it's just the equations from last chapter. And I'm making sure that it meets both the requirements for those.
Okay. Because it's right there. So N and P hat is 0.75.
It's just P. It's just P in this one.
Is it?
Yeah. Because it's saying that it's just a hypothesis test for one proportion.
Okay.
So we're still using the one from last chapter. We're not using P hat.
Okay.
Because it's only giving us P.
Okay, so we need to go to chapter 16.
And they're both going to be 20, by the way. So the smallest is 20.
Did Pete come back with us or nope? Okay. So let's move on to number 12.
11, 10 divided by 100. So the answer is going to be 100.
So show me how you did that work.
So 1/10 is just 0.1.
Right.
So in the equations, you would put it in for P. You would put 0.10 in for P here and 0.10 in for P there, and divide 10 by 0.1. Or sorry, 0.9 because it's 0.1 here and you're doing 1 minus 0.1. So that's 0.9.
Okay.
And that would give you this answer.
Uh-huh.
And then in this equation, when you put in 0.1, it would give you this answer. So in
Okay.
order to meet both, you have to pick the highest one, which is 100.
Right. Okay. I'm glad you're understanding that because I'm completely
Yeah, what-
lost on that.
Yeah, I got it. I got that part at least. I'm not sure how it will go further down the line. Let's see. Okay, so number 13. The conditions for conducting a hypothesis test are satisfied.
Yes, it is because it's a larger sample.
Okay, what is P? So we're doing 30.
No.
30 divided by 80, or 38 divided by 80, 0.475.
Yep.
Find the test statistic. Ooh, excuse me.
You need to go to bed, girl.
I do. I'm getting up there to the old age part, and
Don't even go there.
I'm tired.
Don't even go there. There she is. You made it back, Peace.
Peace.
All right. What question did you drop off at? Are you there, Peace?
Yeah, I am.
What question did you drop off at?
Question 7.
Question 7. Holy cow. Let's catch you up.
Yes.
All right. So question 8, the answer is 0.658.
I think that's question 7.
Question 7 is negative 9.450.
Okay.
Question 8 is 0.658. And question 9 is 0.842.
842.
842. Question
Okay.
10 is decrease.
Okay.
Question 11 is 20.
Okay.
Number 12 is 100.
Okay.
13 is true.
Okay.
14 is 0.475.
Okay.
All right, so now you're caught up with us.
Okay. Thank you.
Yep.
Okay.
All right. So the test statistics now.
Isn't the test statistic equivalent to something?
That's what I'm looking for.
I think it was. I just can't remember what it was. It's equivalent to.
Okay, yeah, the test statistic, the formula is under 4.1. You have to scroll down below the pie graph and under step 4. You scroll down, there's the formula for the test statistic. The value minus the mean over the standard deviation.
Okay. So the value was what again? It was p hat. So p hat is 0.475
Yep.
minus p. What was p?
P is
0.6.
Where did you get that from? Where did you get P from? Oh, there it is. Never mind. I see it.
And then that is all over the standard deviation. What was the standard deviation? Did we figure that out?
We have not figured that out yet.
Okay.
What are you doing?
Okay.
Okay, so the standard deviation, let me get that part first. So we have so we have 6 times 5 divided by, oh, excuse me, n is 80. Oh, not times. 80 is 0.375. And so then we need the square root of that.
Don't forget that we're not rounding yet.
Right. Square root of 0.3. Yeah, it cut off automatically at that, right? 375.
Okay.
And so I get 6.6123. Okay. I need to write that down. That one is a long number, so I'm not rounding that one at all.
Mm-mm.
That number is 0.612,372,4357.
Okay.
So that's the bottom number. And so the top number is P hat minus P. And P hat we determined was 0.475 minus 6.
Sorry, I got it.
What's that?
I think I got my answer, but let's see if it's with yours.
All right. So we got 0.475 minus 6 divided by 0.612324357. I get negative 9.323. Is that what you got?
No. I got negative 0.204124115.
Okay, so all right, let me run through this again. So make sure I'm doing it right. I have 0.475 minus 6.
Minus 0.6.
Oh, 0.6. That's where I'm messing up. Is it 0.6? Oh, it is 0.6. So then my calculation was wrong because I used 6 instead of 0.6 on that other. Is that what I messed up here? Yes, I messed up there because I used 6 instead of 0.6. So I have to do that whole beginning again. Okay, so then it's actually So let me start that part again. So I got 0.6 times 1 minus 0.6. Oops. 1 minus 0.6 divided by, what was that? Divided by 80. So that actually comes to 0.003.
0.003
Yes,
for the bottom part.
for the bottom part.
Okay, so 0.475.
Oh, wait. Well, no. I didn't square root it.
Oh,
My bad. I didn't square root it.
no, you're fine.
Square root of 0.003. Okay, so that comes to 0.05477225558.
Okay.
All right, so then
0.475 minus 0.6 equals that divided by 0.05477225558. And that will give us negative 2.282. Is that what you got, Mike?
no. Is it 0.054? Is that what I read off to you?
0.054.
Okay. So then let me clear that. I have 0.475 minus 0.6. Divide that by 0.05477225558. I got negative 10.479. No, not even close to what you got.
Okay, what did you do again?
I put 0.475,
Mm-hmm.
0.475 minus 0.6,
Uh-huh.
and then divide that by the 0.054. Well, let me back up here. Let me see.
So go back and just
Uh-huh.
do 0.475 minus 0.6.
That's what I was doing. And I get negative 0.125.
Okay, now divide that by 0.054
Uh-huh.
7722558.
All right, now I get the negative 2.282.
Okay.
Is that what you got?
Yeah.
Okay.
Okay. Everyone good on that?
Yeah.
Okay. So let's do p-value now for the test.
I think I found it. It's 1.000.
Okay.
It's on the Excel.
Oh, from that Excel sheet it told you? Okay. All right.
0.0012, is that what you got? Or 0.0011?
No, it's 1.000.
Yeah, because I put the negative 2.282 on the probability applet, and that's not what I got.
I found this as the p-value.
So
But you're right, I didn't. Mm.
well, the p-value,
That's not even our z-score though.
no, that's not even the z-score. Yeah, because Our z-score is negative 2.92 or 292.
282.
Oh, 282. So if you put that in there, it's less than 0.6. So I have a z-score of 0.011 by putting the z-score in the probability applet.
What was it? 0.011?
0.011. Because since we're dealing with a less than 0.06, I'm using the left side, everything on the left side.
Okay.
Is that negative?
No,
Okay.
probability can't go negative, remember?
Oh, yeah. Sorry.
You're all right. Everyone agree with that? Any questions or?
Nope.
All right. All right, we're almost done with this part. We would, let me take a look at that. I think this one we would reject the null hypothesis.
Okay. Yeah, I agree with that.
Okay.
To reject the null hypothesis. All right, number 18. Which of the following best summarizes the conclusion of the test?
Okay. Wouldn't read it.
I would say D. There's sufficient evidence that the quality has decreased.
D?
Yeah, that's
Okay.
because we're rejecting the null hypothesis, which means we're accepting the alternative hypothesis.
Okay, we missed 2.
Which ones did we miss?
8 and 9.
8 and 9.
But I can't turn it in. 7, 8, 9. I have
7.
the answers because it's after 11.
Oh, yeah.
So the answer for number 7 is 0.110.
Okay.
Number 8 is 0.640.
Uh-huh.
And number 9 is 0.860.
Okay. Thanks for falling on the sword.
Proud. You guys did it for me last time, so I owed you one.
Ain't nothing but a thing, chicken wing.
Okay, do you guys want to do this homework real quick?
I would say yeah.
Okay.
Yeah.
Let me open